Hey, this is Kyle from essentialdeveloper.com. Today we will show you how we write tests first. So let's go. Okay, welcome back, Mike.
Hey, Kyle. It's good to be back.
So we got a question.
A quite important one, if I may add.
And probably difficult to answer.
Yeah, it's quite difficult to answer in a small episode, but we'll do our best.
So the question is, I'm trying to understand how you think when writing tests. Do you just try to cover everything that comes to mind? Or you have some kind of list with priorities? Or just try to reach maximum possible coverage?
Okay, a lot of things to cover here.
So this is not just one question, right? There's a bunch of questions inside the question here.
Yeah, there are many books written actually, just about, these couple of questions there. And it comes down to actually having processes and disciplines and following them.
Yeah, I agree. And I follow the basics.
Right.
Right, the basics of the basics of the basics. But it requires some tremendous amount of skill accumulated over the years.
Exactly.
Of doing that basic.
Exactly. So the word basics here, well, don't get tricked by this word, meaning it's not easy, right? Although it's very basic, well, there are 3 steps in the whole process of TDD. It's not the simplest thing, and it's not the easiest thing to follow, especially if you don't know what to do next, how to think, how to frame your problem.
How to break down a problem into smaller problems, especially for beginners, that could be overwhelming.
Absolutely. That's the hardest part, and in my experience, that's the thing that actually make developers quit TDD.
Yeah, so the basic of the basic, you probably heard this before. I'm gonna repeat it. Red, green, refactor.
Right.
There's no magic to it. But with that said, that's hard to do.
Yes.
So what does it mean, red, green, refactor? Well, first of all, we write the test first. We want to see it failing. Because if you write the test first, you don't have the code to make it pass. So this failure could be a compiler error, or it could be an assertion error, or any kind of error that gets in the way of moving forward. Now, I would like to write then the minimum amount of code to make the test pass, to go green. But when I say the minimum, I mean it. It can be like the silliest implementation, but that's important part of the process. Normally, when people are trying to start the red-green refactor cycle, they write a test, they see the red error or assertion failure, and they write a bunch of code, going much ahead of what they need to fulfill that failure.
Which makes it easier to get stuck, actually, because you have to think a lot more ahead than, what you actually have to do at the moment. But you know what? I think that's also the path in order to get to what you said before, being able to practice the basics. You need to understand that. You need to understand when you're implementing more than you should.
And the problem of also writing too much code after a failure is that probably the next test is going to pass.
Exactly.
You also have to ask yourself, do I have enough coverage now? Because I added a bunch of if statements, I have some different flow of controls, I have a for loop, even though I had one simple test. And then the next question comes. Do you try to reach the maximum possible coverage? Well, yes, but that's not my goal. My process, as a side effect, as a positive side effect, makes me reach a maximum possible coverage.
Right. So you're saying basically that the high coverage is a byproduct of your process. And
exactly.
I agree with you 100%. Although, no pun intended, we should aim for 100% coverage. This is not the goal on its own. Having a disciplined process that you try to cover all edge cases, for example, that's what you should focus on. And then if you're doing it right, then the coverage will come.
And it's not always 100%. But if you follow the process, you're going to be very close to it. And in my head, I'm always aiming to 100%, even though it might be unachievable.
Right. And I think we should mention here that, by the way, 100% coverage, it doesn't cover 100% of the behavior. And that's something that many people may not know, but it is true. The coverage is being calculated as if, let's say, the test goes into the method implementation, then it marks that function, that method, whatever, as covered, which, by the way, it doesn't mean that it reads everything, right?
Yeah, and sometimes you need to write some integration tests to give you confidence. And you go and you write the test. Sometimes you need to write a UI test. Sometimes you need to test end-to-end with the API to guarantee correctness, especially if you're talking to an API that you don't trust, that you don't control.
Absolutely. Absolutely. I agree with you.
And even if you're writing integration tests in those cases, I would write them first.
Yeah, that's a little more advanced. But yeah, that's probably a good habit, a good process.
And finally, the last step, refactor.
Yes, which again is one of those words that, well, let's say that not everyone agrees on what refactoring really is. But yeah, it's an essential step, because basically if you don't do that, well, you are working against yourself. You will not facilitate the smooth operation of writing unit tests and testing first, to be more exact here.
You won't get the full benefits of the test. That is like cleaning up your code as you go. So at the end, you can have a very good design.
Absolutely. Avoid duplication, abstract when you have to, and a bunch of other techniques.
All right, so let's write some code.
Yeah.
Talk is easy. So for example, beginners get really stuck because what should I do first? Should I write the test first? But what do I want to implement? What is the minimum I can implement? Should I write a class? Should I write a function? Should it be a struct? There's so many questions to be answered. And this is why following the basics helps. Because if you follow the basics, you don't need to make all those decisions up front. You make them as you go.
Absolutely.
So, for example, let's say you want to test a view controller and that it renders title from a view model, for example.
Okay.
Right, that's probably a common use case in most iOS apps.
Yep.
So the structure of the test, at least the one I have in my mind, is pretty much like a given a scenario or a setup. When something happens, then I expect some behavior to have happened or something to be returned by a function or some side effect. So in this case is that I rendered a title. Now I need to ask myself, how am I going to render this title? Well, if we're talking about UIKit, I'm probably going to render this in a label or a text field. So I would make a decision right now. That is the easiest I can do. And for me it would be a label. So I don't think like, is this label embedded in a table view? Is this label embedded in a stack view? I don't need to think about that. I just create my assertion that, for example, I have a view controller and my goal is to render a title from a view model. So let's say I have a title label and then I need to compare the value that for in this case, I would say a title.
Right.
Now I like to stop here and see that, well, I have a compiler error.
Right. So the compiler is guiding you right now.
Yes.
Right. And this is we're in the red state here. We have a build error. So even though we don't have a view controller class, it doesn't matter because we know that we want to end up with this.
Yes. So I have a couple of options right now. I can either carry on going up the chain and implementing my when block or my given, or I can satisfy the compiler now. In my head, those are options that I can exercise.
Right.
Now, if I'm pairing, I would ask my pair, what do you think right now? So Mike, what would you do right now?
Well, to be honest, if I'm writing it by myself or if I'm writing with you, that we know how we work together, I'm gonna continue it to the when part and then the given part, just because I can visualize this code, you know. However, if I'm starting out as an exercise, I will stop here. I will go create a view controller class. I will add the label, and I will then make sure I don't get any build errors and continue the testing process.
Okay, so you're saying that you prefer to fix the build errors first?
Yes, for now, yes.
Okay, so let's say we have a view controller. And let's say for the sake of this example, it's a title view controller.
Right, very simple. I like it.
Now, would this be enough? Well, we fixed one problem and now we have another one.
Right.
Again, the compiler helping us make decisions right now. So we only write the code as we need it. Now we can create even a class in the same file and then extract it.
Yeah.
Okay. Now I just need to have a title label in there.
Mm-hmm.
So title label, UI label.
Yeah, for example, yeah.
Well, it needs to be equal.
Yeah.
We are assigning.
Right, so now we don't have any more build errors.
So we can carry on.
We can carry on, exactly.
Right, so now I have a couple of options. First of all, this setup doesn't match, right? I'm not passing the string a title.
Yes.
In here. So now I can make a decision of just passing a title here as just data.
Mm-hmm.
Or I can create a view model. But I would carry on as just adding something simple for now.
Okay.
So for me, the string is the view model at this point. It is the data.
That makes sense.
So I'm going to have to create a convenience initializer that starts with a title property. Now I can call init. No build errors. Now we can carry on. Now, what should happen for the title label to render the correct data?
Yeah, we're looking for an action, and render is the action here.
And in a view controller, rendering means loading the view.
Exactly.
Okay. So if we say view controller dot load view if needed, for example.
Yeah, we don't get this completion because we're not inheriting from UI view controller.
Exactly. If I run the test, it should fail. Yeah, it fails.
Okay.
So we made a couple decisions right now, and those decisions are not final. In my head, they are just the minimum to set up a first scenario. But this design can change. Maybe I'm not going to pass this data in the initializer anymore. Or the action is not calling load view if needed, but actually invoking a method render by passing a view model. But this is enough to have the first failing test, the first assertion failing, so I can move on.
Right.
So in this case, we can have the view did load here. And now we can set our title label text to equal the title. The problem is that view controllers already have a title property. So let's say for now, this is an internal name, title data, for example.
Yeah.
Or you don't even need the view did load, actually.
Yeah, we can put it in the initializer.
We can put it in the initializer, exactly. We can say title label.text equals title. Because this is the minimum we can do to make the test pass. Okay. And it passes. So now going further, we can add more properties. Instead of passing just a title, we can have a subtitle, and then we can have a collection of data, and then we have to create a view model combining the different kind of data so we can pass to the view controller to render it. And maybe we don't have these data in each time. We need to pass it in the future. So thus I would have a method like render, and I would pass a view model, for example. But that would be part of the evolution of the design as I go.
Absolutely. Absolutely. This is not needed right now. And well, this is one of the things we mentioned earlier, that although you know that you're going to end up with something like that, you probably don't want to start like this because you make so many assumptions that increase the risk of doing something wrong in the process.
And you need to ask a lot of questions up front. For example, who's going to give us the view model? Should I have a collaborator that creates view models? Should I talk to a networking layer? Well, those are details I don't need to know right now. I want to leave those questions open until I get to the point where I need to implement them.
Right, absolutely.
So I solve one problem at a time in very tiny steps. And you may think, oh, this is very slow, but when I'm coding this off camera, I'm super fast.
Yeah.
I've been doing this for a long time and you just get faster and faster. And by following this process, you're much more productive because when you write the tests after the fact, your code is probably not going to be very testable. You're going to have to hack around and probably swizzle some methods. You're going to have to inject some singleton with some networking data, but it might work well for you. But if you're trying to write a test first, I really advise you to do one tiny step at a time, trying to solve one tiny problem at a time. And I would commit at this point, for example.
Yes, excellent advice, in my opinion. That's another thing that is not very common. Committing with every single test. Well, you create basically a checkpoint where if you do something wrong or if you do something you don't like, you can always reset to the previous to the head, and you don't have to Command Z, undo everything. Yeah. And risk losing something that perhaps you missed.
Yeah, so we went to the red, green, and now it's the refactor time.
Exactly.
Right, so anything to refactor in the code here? I don't think at this point we have anything to refactor.
Maybe we can clean up a little bit, the comments. And personally, I like calling the system under test with the acronym SUT. So instead of view controller, I would like that to be renamed to SUT.
So the convention system under test is just a way to easily identify what am I testing in this test. Because I've seen a lot of tests in my career where the setup is so big. You have view models, you have databases, you have networking objects, all in the setup. And I'm asking myself, what are they testing here?
Right, exactly.
What kind of behavior am I expecting? Like, what is the system under testing here? Maybe it's the cluster of all the objects. And maybe that's what you're testing. But most of the times you're testing one thing, but it's hard to identify it. So by using some kind of standard, like SUT, for example, we instantly tell the reader that this is what you're testing. Everything else is just data or collaborators.
Right. And since we're on this topic, maybe we can even rename the test.
Because we thought about the problem too much upfront.
Absolutely. I agree with you.
Right. So the concept of view model might appear. It's something in the back of my mind that at some point I might have to create one. But right now, we don't need it.
The behavior that you want right here is to render this title. Where it's going to come from, that's a totally different thing.
Yeah. So in my head, the given when then is always there, but I never actually type it as comments. That's pretty much how a test I write would look like. And we can even ask the questions like, do we even need this load view if needed? Maybe we make this assumption when we were writing the code, but during the refactoring phase, we find out that, well, we also don't need this. And we can get rid of it. Because it doesn't mean that we write the test first, we get everything right first.
Right.
Right? We need the refactoring step to guide us to the right code. First, we write our assumptions in there. Then we write the code to make it pass. Then we ask ourselves, is this the right thing to do?
Yeah, and I think it's especially important not to be a victim of sunk costs there. Just because you did something, it doesn't mean that you can't change it or you won't change it because you did it before. That's the essence of software, things need to be soft, fluid. You need to be able to change things all the time. So absolutely, this is one of the big principles in my opinion.
Yeah, and maybe at this step of refactoring, you can say, actually, I don't like passing the title up front. So then we can have a render function here with title, and we convert these into a render function, for example, and then we can start designing our APIs as we want it. So that's why we have a process, and we are free to make changes. We don't make rigid decisions. We want the decisions to evolve as we need it.
Yes, absolutely.
And all of those design decisions, although people say they come from the tests itself, I think they mostly come from experience. And of course, the test helps you ask the question. The test allows you to make those decisions and change those things with confidence. But those decisions don't come from the test. The tests don't make design decisions. Developers do. And that's the process. That's the basic process. And that's how I write tests for everything. It's basic. It's simple. It's so simple that you might not believe that's what we do, but that's what it is. But it doesn't mean that something is simple. It's easy to do. It requires practice. And we practice this every day for years. And the daily practice compounds. So if you're aiming to write a test first, I highly recommend you to follow those 3 basic steps. And with time, you get better and better. You're going to be able to break down problems into tiny, tiny, tiny problems. It's a skill. With time, with practice, you're going to get better at it.
Yeah, and studying, right? Not just videos and books, but other people as well.
Pair with people, ask questions. If you have a senior that can do this in your team, or you have a friend, just, I don't know, pay them a coffee, bring a laptop.
Yes, exactly.
And practice. Just watching videos and reading books might not be enough. You need to practice. So follow the process will allow you to change code with confidence. Will give you, at the end of the process, a high coverage. You're going to be managing risk as you go and decreasing the risk of change. And as you practice, you get faster and faster. So just keep practicing. And if you can, and if you have the opportunity, just learn from someone, get a mentor, watch videos, read books. But at the end of the day, you have to go there and do it. So I hope you enjoyed this video and learned something today. Don't forget to check the description for more links. Don't forget to subscribe, and I see you next time.
Bye, y'all.